So these questions are meaty, but we're going to work our way through it and we're going to figure out some cool things. A cylindrical aerosol can has a lid in the shape of a hemisphere. So that just means it's half of a sphere. If it's a hemisphere, half of a sphere. That fits exactly on top of the can. The height of the can is 16 centimeters. So that's 16 centimeters. And the radius of the base of the can is 2,9 centimeters. They've told us what the volume of a sphere is. So if we're wanting to get the volume of a hemisphere, we would just divide that by 2. And they've told us the surface area of a sphere. Okay, so for the very first question, it's asking us to calculate the surface area of the can with the lid in place. So that's this whole surface area, the lid and the can. Now, if I was doing the bottom part of my can, so this part over here, okay, the surface area that I'm going to include is all of this outside area of my cylinder and the bottom base circle. And remember, when we break up a cylinder, we get a rectangle, and then we would get the 2 circles, the top and the bottom. And this rectangle, this part over here, the circumference of my circle, that is the length of our rectangle. So to get the circumference, we would say 2 pi r. That's going to give us the length of the rectangle. And this is the height of our cylinder, which we know is 16. So this over here would be 16. So then you can find the area of that rectangle. You can find the area of the bottom circle, this dude down here, by doing pi r squared. And that gives you the cylinder. Then all you need to do is the surface area of the hemisphere. So the surface area of a sphere divided by 2. So in total, our surface area, we're going to have a rectangle plus a circle plus the hemisphere. That's my hint to you. Give me a thumbs up when you're feeling good, and then I'll let you know. Laika, I can't teach you guys physics. I haven't done physics since I was in high school. I promise you do not want me to be teaching you physics. Okay, good. I'm glad you know where. Saying nothing. Giving everyone a chance to give this a try. Let's see if people agree with you or not. Give it your best go, everyone. I've broken it down a little bit for you. If you're feeling completely lost, let me know. I'm happy to help. No, don't say you don't know what's going on. I've tried to help. This is supposed to be helpful. Oyanda, I know you know how to do this. You're able to find this rectangle. You have R, you have pi, you have 16. That's your rectangle. You're able to find the area of the circle. You have R, you have pi. You're able to find the hemisphere because you have R, you have pi, and you're just dividing it by 2. So I know you are able to work all 3 of those out. Yes. The formulas that I give you here are the ones that will be given to you so they won't be in the formula sheet. They will be given to you in the question like this. But the ones that they don't give you are like your rectangular prism, your cylinder, those ones they don't give you. But they will always give you things for like a sphere, a pyramid, those dudes. But like we would need to know that like a cylinder is going to be a rectangle and a circle or 2 circles, depending on what it looks like. Why not? Because it's considered assumed knowledge because it was taught to you in grade 9. So it's considered that it's been taught to you long enough ago that you don't need to be given it. Don't argue with me. I don't make your exams. Okay, I'm going to give you 3 more minutes to finish off this question. At the moment, just focusing on 8.1. If you finish with 8.1, please feel free to do 8.2. But for now, 8.1. Because if we only had one hemisphere, we would only have half of an Earth. That's why we have 2 hemispheres to make a sphere. Also, if we had a hemisphere, that could be quite cool like we would have a flat bottom. Imagine like living on this part of the hemisphere. Wonder what that would be like as it rotated. I suppose you wouldn't feel it because of gravity. Okay. Last minute, 10-2. I'm going through the answer for this one. Hi, Yvonne. Hi. Okay, so let's go. When we're working out this dude, we're going to follow this little green structure that we made over here. So for my surface area, this is for 8.1. My surface area, I'm going to do my rectangle and my circle. So that's part of the cylinder base. And then I'm going to add my hemisphere, which is going to be the lid of the spray can. Okay, so my rectangle is like we spoke about up here, 2 pi r times 16. My area of my base is going to be pi r squared. And then my hemisphere is going to be 4 pi r squared divided by 2. Okay. Now, all we need to do is put in r, which is our information. So 2 pi times 2 comma 9 times 16 plus pi times 2 comma 9 squared plus 2 pi 2 comma 9 squared. And then we get to chuck that straight into our calculator. So 2 pi and we get the beautiful answer of 370,80 centimeters squared because it is surface area. Okay. 8.2. 8.2. If the lid is 80% filled with a liquid, as shown in figure 2. So as you can see over here, this is figure 2. So this is 80% filled with liquid. Calculate the volume of the liquid in the lid. So we need some things here. We need the volume of a sphere. That's this dude over here. Okay. And if it's a hemisphere, we're going to divide that by 2. And then you're going to work out what 80% of that volume would be. So what 80% of there you go. Give that a try. Ooh, getting an answer. Let's see if we agree or if we disagree. Something may have happened, Uyanda, if your number is almost 20 times that. Okay. So this is what we're working on for 8.2, right? So 80% of 4/3 times pi times 2,9 cubed divided by 2. So that's going to be 80% times, I'm going to put all of that in my calculator and I get 51,0802. So I'm going to times that by 80%, and I'm going to get 40,86 centimeters cubed. Chidimalo, can you see where yours was different to mine? Let me know if you see where you went wrong. If you don't, catch it yourself. Okay. I'm taking that O as a good thing. I'm going to zoom out a little bit so that you can see the whole question. In case anyone would like to take a screenshot, please feel free. Okay. I think you'll like the next question. It's a little bit nicer than this one. Is that the one I wanted to do? Okay. So Uyanda, like I said earlier, so as an example, these questions were all taken straight from your DBE papers, and it was exactly written like this. So this box with the formulas, that's exactly how it was. So you don't need to panic. They will always give you that. Okay. So we've been given the surface area of our cone. They've told us that S over here is the slant height. That is your S over there. That's your slant height over there. They've told you that the volume of your base. They've told you, so we've got all kinds of things going on over here. We've got the volume of our cone, and then we've got, well, we'll come to that now. When we're having a look at this, the first thing I want your brains to always jump to is as soon as you see a cone, and often a triangle, like a square pyramid, Trig is often your friend, absolutely. And Pythagoras is your friend. Trig and Pythagoras. So you can easily find things using your trig over here. And then you're able to get your S, which is your slant. You're able to get your R. And then you can start working these things out. If you want to like put your things along, okay, I'm seeing a big so. Let's see what follows that. Okay, double check. Let's see if people agree. If they don't disagree. 6 marks in your pocket if you can get this one. Two more minutes. 2 more minutes, and then I will do it with you. Okay, so let's figure out the things that we need over here. We need R. If this is theta, we've got our adjacent and we are looking for our opposite. So we care about tan. So tan of 36 degrees is going to be opposite, which is R, over adjacent, which is 2. So that means that 2 times tan 36 is going to be equal to R. So 2 times tan 36, which gives us R is 1,453. And I'm going to keep 3 decimal places just to keep my number as accurate as possible. Okay. Then we need to find our S. So you can find S by using Pythagoras, or you can find S by using trig. Either way, doesn't matter. So let's keep on the trig train while we're at it. So if we've got adjacent and then hypotenuse, we're looking at cos. So we would say cos of 36 degrees is adjacent over hypotenuse. Yes, it's an S. Does it look like? Oh, sorry. No, you're not. Lots of my students have moaned at me for my S's and 5s over the years. Two over cos 36. And so S is going to be 2,472. Okay, so we have S and we've got R. That means we can do everything we need for our surface area over here. So for our surface area, we've got pi times r squared. Now we know r, so that's 1,453 squared, plus pi times r, 1,453, times s, 2,472. And we pop that into our calculator. Exactly like that. 1,453 squared plus pi times 1.453 times 2.472. And we get the beautiful answer of 17,92 centimeters squared. Nice work, guys. Take a screenshot if you would like. Nice job, Teboho. And then we can get on to our next question. Okay. Oh, this is a nice question. A solid metallic hemisphere has a radius of 3 centimeters. It is made of metal A. To reduce its weight, a conical hole is drilled into the hemisphere, as you can see below, and is completely filled with a lighter metal B. The conical hole has a radius of 1,5 centimeters and a depth of 8/9 centimeters. So this is 1,5 and this is 8/9. And then it's also telling us that this whole hemisphere has a radius of 3 centimeters. Calculate the ratio of the volume of metal A to the volume of metal B. If you need the volume of a cone, it's your third pi r squared h. So think about it in two different ways. This is how my brain would think about it. Remember, all of our brains are different though. I would work out the volume of our hemisphere. So we know that that has a radius of 3. Then I would work out the volume of the cone inside. We know the height of that cone. We know the radius of the cone. And then once you've worked out what those two are, then you can take the one minus the other. You can play around, but getting these two is your first important stop. So make sure you can get the volume of your hemisphere and the volume of your cone. And just as a little helping hand for that cone, I think that'll just overcomplicate things. But you have everything you need. I'll be 2 minutes, guys. I'm just going to turn the light on. What's the big O for? What have you just figured out? Okay, 2 more minutes. Okay, we're going to do this in steps. So I'm going to start with the volume of my hemisphere. So the volume of my hemisphere, the full hemisphere, so imagining nothing was cut out, it would be 4/3 times pi r cubed, right? Okay. So 4/3 pi r is 3 cubed. Cool. That would be my hemisphere situation. So I'm actually just I'm gonna work that out and get a number. So times pi times 27. So this is gonna give me 36 pi. That's my full hemisphere. All right. Then let's work out the volume of the cone. So the volume of our cone is going to be 1/3 pi r squared h. So that's 1/3 pi times 1.5 squared times 8/9. I'm going to chuck that into my calculator now. So 1/3 times pi times 1.5 squared times 8/9. And that is going to give me 2/3 pi. Okay, so now I have my cone and I have my sphere. They're asking for the ratio of volume of metal A to the volume of metal B. This is the volume of metal B. Because that's our cone. But to get the volume of metal A, we have to take our hemisphere, so our 36 pi, and minus our cone. And that is going to give us the volume of our hemisphere minus the cone. So 2/3 times pi. And that is going to give us 106/3 pi. Okay, so now we have everything that we're needing so far. Oh my goodness, Uyanda. Yes, thank you. What a nincompoop I am. Look at that, being an absolute nincompoop. We're going to divide this by 2 because that's a sphere. We're going to get it into a hemisphere. So this is going to be 18 pi. Such an nincompoop. I'm so sorry. (18 pi minus 2/3 pi is going to give us 52/3 pi. Okay, so now what we're wanting to do is we're wanting to get the ratio of these. So if I write that out, my ratio of volume A to volume B is 52/3 pi to 2/3 pi. Now, what do we get to do when we're in a situation like this, when we're looking at ratio? Like if I was looking at a ratio of 2x to 5x. What is that actual ratio? It would just be 2 to 5, right? So in this case, what we're doing is we've got the pi's on both sides, so they cancel. We've got a denominator on 3 of both sides, so they cancel. So what we're left with is 52 to 2. And then we want to simplify that as much as we can. And that's going to give us 1 to 26. And that is going to be our final ratio of metal A to metal B. Why did I subtract? Because my hemisphere metal is if all of this was metal, right? But I don't want to include the metal that is the cone on the inside. So I'm taking that out of my volume so that the only volume I'm left with is the outside part. So my hemisphere minus the cone. Because the cone is going to be a different metal. Yeah, exactly. If it had been outside, I wouldn't have had to. No. Shall we do one more? One more for the night? Okay. A spherical glass ball is tightly packed in a box. The box is in the shape of a cube, as shown in the picture on the left. The radius of the ball is 6 centimeters. The diagram on the right shows the cross section of the ball placed in the box. What volume of the box remains after the glass ball is placed in it? I'm going to give you guys some time. You have everything you need for this one. So it's a cube. So that's one of the ones that they won't give you. At any type of sort of prism shape, like a rectangular prism or a triangular prism, it's always going to be the area of the base times the height. So if this is my cube, then I know you just need to find its length. So side times side times side, and you'll get its volume for a cube. Or just think of it as area of base times height of shape. Good. Yes, exactly. S is going to be 12. So this is my radius, and it's going right to the edge. I'm not going to tell you, Abu. Some people agree. Look at that. Okay, so we're hating measurement a little bit less. I'm going to take this. I have some spicy questions for you on Thursday, but it's not like it's sort of incorporates some trig because I think that they might ask it that way. So there's trig and measurement together in a question on Thursday. So let's see how you feel, Abu, when they're one and the same. Okay. All right. So for this one, we need the volume of our box, and then we need the volume of our sphere. So let's start with the volume of the cube. That's going to be side times side times side, which is 12 times 12 times 12, which is going to give us 1728 centimeters cubed. So that is our cube. Then we need our sphere. And that's going to be 4 over 3 pi r cubed. So 4 over 3 times pi times 6 cubed, which gives us 288 pi. And so the volume that remains after I put my sphere inside the box, so remaining volume, is 1728 minus 288 pi, and that's going to give us 823,22 centimeters cubed. If your decimals are a little bit different, it's okay. It just means you rounded off earlier than I did. Please feel free to take a screenshot. I think we should do one really nice, easy question to end. So any prism where it's like the same shape throughout. So as an example, like if I had a rectangular prism, it's a terrible rectangular prism, that would be area of base times height, and you could use any of the things. If you had a triangular prism, something like that, then you always take the area of the shape that we're talking about. So this is a triangular prism. So the area is the triangle, and then this would be the height of the shape. So in here, there is my base. This is my height. if you do a cylinder, it's exactly the same idea. The cylinder is the exact same thought. All it is the area of the base times the height. So as long as the shape is the same throughout itself, like if I did a cross section through any of these, like if I cut that halfway through, I'm going to still see a triangle. If I cut that halfway through, I'm still going to see a circle. Then it's fine. As soon as we get into different shapes, like a cone, for example, it's not the same. Then I can't use that idea. Or a prism, like a pyramid, I can't use that idea. Okay. Let's do a nice, easy question to end on. This area over here, this big A, is talking about the area of the base. The question here is to find the volume of the pyramid. What is the volume of the pyramid? No trick. Nothing tricksy. Just something nice and easy for us to end on. It's not the midpoint of the base, but it is the height. It's our perpendicular height of our pyramid. It's going to be a big number, yes. Okay. Give me one more minute. Okay. So we're going to follow our formula here. The volume of our pyramid is a third times the area of our base times the height of our pyramid. So a third of 192 times 192 times the height of our pyramid, which is 28. We're going to pop that straight into our calculator exactly like that, and we should get 344,064 meters cubed. Yay. Nice work, guys. You did good. Okay, we will do